Good morning. Today I desire to have a discussion with you regarding the applications in the pharmaceutical industry sector. This is about the thermostating of reactors used in the chemical pharmaceutical sector. The uses are numerous because they range from small laboratory reactors to large reactors for the production of pharmaceutical active ingredients, as well as simple mixers of chemical or cosmetic substances. The concept is always the same. In practice, these systems need to be maintained at a temperature that enables the preparation of the product inside through a series of temperature increases and decreases, thus facilitating the heating and cooling of this product at different temperature levels. So, how does it actually work in practice? These reactors are simply large vessels, let's say, with mixers inside, jacketed. In the shirt of these reactors, a hot or cold fluid is made to flow, which precisely heats and cools the product inside. Very straightforward solution. You can transmit the hot fluid, the cold fluid, so steam, instead of cold water in this shirt, and you obtain the effect. The disadvantage is that when I have to switch from steam to cooling water, I have to completely empty the jacket, circulate the cold water with technical times, and moreover, there is a possibility of pollution of the intermediate fluid that is used to heat and cool our product. The solution is to use control units called single fluid units that have a fluid circulating in this jacket and is heated or cooled through heat exchangers and control valves. How does it work in practice? There is a pump that constantly recirculates a fluid in this jacket, in this reactor half tube, and based on a set point set by the customer, by production, through a PLC that interfaces with this control unit, the valves on the heat exchanger in the steam open to heat this fluid, rather than the valve on the cold water to cool the fluid that continues to circulate. Obviously, there are many systems. We have control units with electric heating and water cooling, control units with multiple temperature levels, steam heating, cooling with water duct, cooling with chilled water to reach very low temperatures. Let's say that they are extremely customized control units. Also because we work in safe environments rather than ATEX environments. Control units needed for US market, hence UL standards apply. Also required for Russian markets, thus as per requirements of EAC. In practice, there are really a lot of variants. The concept of operation, however, is always the same. So having a fluid that continues to circulate on the reactor that is cooled or heated by utility fluids that are introduced into the control unit. What are the advantages of this system? Those of having a constant circulation of fluid, not having pollution between the various operating fluids, and having a wide processing range without pressure controls, because we have a single fluid that recirculates on, which we can control pressure, control flow, manage temperatures very precisely, with ramps up, ramps down, have controls especially on very refined set points, because clearly, with PID systems, modulating valves, refined control systems, we can obtain a temperature tolerance that we need inside our reactor, our production machine, let's say, very, very precise. We will delve into the topic. Thank you.